Okay. So the second quiz question is multiplication. You're going to multiply these two, but it's not going to look like this. You would actually have me on the quiz prep that I sent on Monday, and the one that we did on Monday in class, you have to simplify what's in the parentheses, then you can multiply it together. Question number one is addition or subtraction. You have to simplify what's in the parentheses and then change it into imaginary numbers, complex numbers, and then add or subtract like terms. So at the end of class at 10 o'clock, we'll look at the quiz prep before I give you the quizzes and send you up on your way. But we do have to do the 2.4, 2.5 notes, which is solve the equation. So this is just a little warm up in terms of multiplying. And then we're going to get into our factoring. And before we can get into the factoring, we got to make sure we can distribute and multiply. So here, this is distribution. And that means every term in the first parentheses has to distribute to every term in the second one at a time. The rainbows help organize things. You get the 5 times the 8. So it's a positive times a positive. It'll be a positive. 5 times 8 is 40. And then a 5 times the negative 3i. So a positive times a negative, that's going to be a negative. 5 times 3i, that's a negative 15i. So we're done with the 5. Now it's the 4's turn. We distribute the 4. Sorry, the 4i, positive 4i. So positive 4i times positive 8 is a positive 32i. And then here comes the troublemaker. The last time class when you're dealing with imaginary numbers, you have a positive times a negative. Get that sign right. Positive times a negative is going to be a negative. 4i times 3i. 4 times 3, that's my 12. I times I is going to be an I squared. So now we simplify what we can. 40. There's no other real numbers. 40. You have negative 15i and a positive 32i. You treat it just like a variable. So negative 15i plus 32i is a positive 17i. And then this right here, remember, you're only ever going to have an I to the first because the powers of I will change. I to the first, you would just simplify as an I. An I squared is equal to a negative 1. You would change it and simplify it to a negative 1. An I to the third is a negative I. An I to the first. An I to the fourth is a positive 1. And then it repeats. That's from last Wednesday. I to the fifth goes back to an I. I to the sixth is a negative 1. I to the 7th is a negative I to the 8th is a 1. And then it repeats. So this I squared, this is negative 12. This is that negative 12. And that I squared is a negative 1. So this ends up being a plus 12. So we have a 40 plus 17i and then a plus 12. So we now actually have a couple of real numbers that we can still add together. 40 plus 12 is 52 plus 17i. So when you multiply these two together, we get 52 plus 17i. And that's what it should look like. It should look like a complex number. It should look like a real component plus an imaginary component, an A plus BI. You shouldn't have 3 things. You should have one term that's real and then one term that's imaginary. Worst case scenario, you would have just a real number because the imaginary part adds up to 0. Or just an imaginary part because the real part adds up to 0. It just depends upon what you end up with. But you're not going to have 3 things when you multiply complex numbers. Any question on it? Same deal here. Now, you need to start recognizing when it looks like this pattern. That's a 9, that's a 9. The first terms are identical, they're the same thing. That is an I, that is an I. The last terms are the same thing. The only thing different between these two complex numbers, this is plus, that's a minus. And it wouldn't matter if this was minus and that was the plus. They're exactly the same thing, except the signs are different. Okay? We still distribute. So we get 9 times 9, that's 81. 9 times positive I, that's a positive 9I. Now we distribute the negative I. So this is a negative times a positive. A negative times a positive is going to be a negative. I times 9 is negative 9I. And again, the last times last, when you're dealing with imaginary numbers, that's the tough part. You have to keep track of the sign. Negative times a positive, going to be a negative. I times I, that's an I squared. So the only real number we have right now is our 81. Positive 9i minus 9i. What happens to these two? They cancel out. We get a 0. And then this. We have minus, what's I squared? So minus a negative 1, so it ends up being plus 1 right here. And 81 plus 1? The answer is 82. So 9 minus I times 9 plus I equals an 82. I just multiplied together that concept. Make sure I'm on the screen here. Over here, no. The 9 minus I times the 9 plus I is this multiplication. A minus B times A plus B. It's a special product. You have exactly the same terms, got A, got B, but the signs are different. When you multiply this together, it will always be the difference of two perfect squares. A squared minus B squared, because in the middle, they cancel out. In the middle, outside times outside, A times B, that's a positive AB. Inside, negative B times A, that's a negative AB. They're always going to cancel out when I multiply something that's the same two terms, but the signs are different. So I could have just gone to, this is going to be 9 squared minus I squared, because it's A plus B times A minus B. If you don't want to use that special product, don't. Multiply it out, distribute, or use the word FOIL. Practice it, whatever you choose to do with it. Just get it right. That's the goal. Whatever makes you get it right, you do it that way. Okay. 3 and 4, we're just distributing the one term into the two terms. You got to treat it like Skittles. Treat, respect the rainbow. What is come on? Love the rainbow. Like the rainbow, treat the rainbow. I don't know. Basically doing the rainbow into the parentheses. When you distribute, that way you keep track of what's been multiplied. It's x times 3x. X times 3x is 3x to the second. And then a positive times a negative is going to be a negative. When I do the next part, I take care of the sign first. It's a positive x times a negative 2. So positive times a negative is going to be a negative. Take care of the sign. And then x times 2 is just a 2x. And that's done because you can't go any further. You can't combine an x squared with a 2x. They're not like terms. Okay. I'm going to go straight to the answer, but if you need to see more detail, you tell me. We distribute. This is a single term times each individual term. 5x to the third times 2x to the second is 10x to the fifth. 5x to the third, positive times a positive, going to be a positive. 5x to the third times 5x. So 5 times 5 is 25. X to the third times x, that's an x to the fourth. And then 5x to the third times a negative. So positive times a negative is going to be a negative. 5x to the third times 4, 5 times 4, that's a 14x to the third. And you can't combine anything because they're not like terms. The powers are different. Any clarification there? Yes. Here's why we're doing this multiplication. Factoring is reversing the distribution. If I gave you this problem and I said factor it if possible, then what you have to do with this question is figure out, this is a subtraction, a difference problem. How can I rewrite this as a multiplication problem? So you're going to be looking for the greatest common factor that I can take out of each term. Well, they each have an x in common. So what happened was, over here, we distributed the x using multiplication. So when you factor out the greatest common factor, when you take out that x, you're going to divide each one by an x. When you distribute, you multiply. So when you factor it out, we're going to divide. 3x squared divided by x is 3x to the first, minus 2x divided by x is just the 2. And you go back to where we started. That's what factoring looks like. We take a difference and it becomes a multiplication problem. What does it look like as a product? Same thing here. We're looking at, we're at the rainbow there. We're looking at these three terms, and we want to know, first thing we do with factoring is take out the greatest common factor. So I would look at the 10, the 25, and the 20. What's the biggest factor that I can take out of a 10, a 25, and a 20? Well, the biggest number I can take out of a 10 would be a 10. But 10 doesn't come out of a 25. I can take a 10 out of a 20, but it has to come out of everybody. So I can't take a 10 out of everybody. What else can I take out of a 10? A 5. Can I take a 5 out of everybody? Yeah, 5 goes into all three of them. So I can factor out a 5. So I'm going to factor out a 5. And you can see the reverse rainbow happen. And then I'll look at the variables. An x to the fifth, an x to the fourth, and x to the third. It's like these three terms are going out to lunch. But they're going to split the check equally. So they can only pay as much as the cheapest person at the table. The cheapest person can only pay as much as an x to the third. So that's the most this person can give up. So the most you can take out of each one is an x to the third. They at least have an x to the third in common. So when I factor out, we're going to have to do it above. Sorry about the rainbow. Real rainbow. So taking out the 5x to the third, everybody's going to get divided by 5x. And divided by 5 is a 2. X to the fifth divided by x to the third. When we divide, you subtract the exponent. So x to the third goes into x to the fifth, leaving x squared. Plus 5 goes into 25, 5 times. X to the fourth divided by x to the third. 4 minus 3 leaves an x to the first. Minus 5 goes into 24 times. And x to the third divided by x to the third is 1. And it takes us back to the original question. That's the whole point of factoring. On your test next Wednesday, you're going to have one problem where it says you have to solve the problem with factoring. Any other method, you get 0 points. You have to solve it with factoring. And then you're going to have, I think I did show you on Monday, but several problems where you get to choose your own method. And I'm going to keep saying try factoring. It's the quickest, nicest, simplest way to get to the answer. And I promise I'm going to give you plenty of factorable problems. Try factoring. Okay? If you take care of the factoring, you can be done in 45 minutes, maybe an hour on the test. But you got to get to the factoring. I got to be confident in the factoring. Now, we've done things like 5, 6, and 7 many times. Well, 5, 6, 7, and 8. Those are special products. Five. Hopefully, we're all at this stage. This is x squared plus 10x plus 25. This is 9x squared minus 24x plus 16. This is x squared minus 144. This is 100x squared minus 25. And if we're not, we're still okay as long as you're not putting this, as long as you're not going x squared plus 25. You have to get past this because your brain has to tell you. I keep putting that answer, but I know every time I put that answer, that's not what we're doing in class. There's something that doesn't feel right every time I put this because it's like I keep touching the hot stove and I keep getting burned. There's something different when I have to do this. So what else can I do if I don't know the special product? You can choose that word, special product. You could always multiply it times, times itself. That's what a square means. And distribute. X times X is the X squared. X times positive 5, that's a positive 5X. Positive 5 times X, that's another positive 5X. 5 times 5, that's a positive 25. There's my X squared. 5X plus 5X is the 10X in the middle. And there's my 25. But we can't keep doing X squared plus 25 anymore. That's got to feel, there's something wrong with putting things. Same thing with 3x minus 4. You can always expand it. 3x minus 4 times 3x minus 4. 3x times 3x, 9x to the second. Positive times a negative. Negative 3x times 4 is negative 12x. And then you have a negative times a positive, 4 times 3, another negative 12x. That's how you get the negative 24x in the middle. And then a negative times a negative, that's a positive, 4 times 4, 16. So those special products that we just did, this is A plus B, perfect square. And we square the first one, and then you multiply A and B together, and you double it in the middle, 2 times AB. So I multiply X and 5, I get 5X, and then I double it. Double 5X, and I get 10X. You multiply the 5X, and then you double it, I give you 10X in the middle, 2AB. And then it's plus B squared. B is a 5, 5 squared is 25. This is A minus B. Now, compare these two. A minus B squared. Before you start thinking, oh, look at all the things I have to memorize. Well, A minus B is exactly the same terms. It's got an A squared. It's got a 2AB. It's got a B squared. This one's even a plus. The only thing that's different when you do subtraction, this is minus instead of plus. It's minus 2AB in the middle. That's the only difference. You square the first one. I squared the 3x. 3x is the second. 9x squared. Then I multiplied A times B. 3x times 4 is 12x. It's minus 2 of those. So minus 2 of those 12x's. Minus 24x. And then plus the B squared. So plus a 4 squared. Plus 16. That's if you want to apply the special product. You don't have it. When we do 2.4, you have to solve equations with factor. You have to solve equations with the square root method. And there's a little something called completing the square. Complete the square. You will end up getting these two. From here, you will go to here. Now, here's the good news. If you do the steps in completing the square properly, you won't have to work it backwards to get to this. It will automatically be this. So again, when I give you the notes, I've already wrote down all the notes for all the steps in today's lecture. If you opened up the email that I sent, you opened up the announcement that I sent last night, you already have it. Otherwise, I had it printed out. That one is just A plus B. And those are the same two terms. And this is a minus in between, minus B. So when you multiply this together, you get the A squared minus the B squared, difference of two perfect squared. So when I did this, I just went X squared minus 12 squared. Which is important to see. Did this become a plus 144? Obviously not, because I'm not squaring the negative. It's subtraction. The only way you're going to square a negative is if it's in parentheses raised to the second. X squared minus 12 squared. And that's my whole point about if you don't have the negative in parentheses, that's negative 144. If you have the negative in parentheses, that's a positive 144. It matters. Okay. So that's another special product. If we have the difference of two perfect squares, it's because we multiply the same two terms with variance and substance. It's our special product. But you know what? Equals goes in both directions. If I multiply these out, I get these answers. But if I have these answers, I can factor it and get these products. It's just about recognition. I've seen something like this before. Don't have to. I'm going to show you how to get there without memorizing. But the more you actually do. And why is that row back there pulled up? I pushed it back, right? Why do people come into my house start rearranging my furniture? I'm never going to somebody else's house, start pushing the couch around. So we need to push that row back. They don't need the row. The back row, we need to put it back in. All those, no, we don't need those back row. This row's getting too close. Didn't want that row that close. So that all of that row, everybody's home. You can move up one, but yeah. It gives you more room to walk through and all. Same thing here, 10x times 10x, 100x squared, and then in the middle, we have negative 50, positive 50, that cancels out. Positive 5, negative 25. Okay. Nine, 10, and 11. Well, these last three do not look like any of our special products, so you're just going to have to FOIL it out. Some of these examples specifically with objective in mind. So when I multiply this out, distribution, 3x times positive 3x, that's a positive 3x to the second. And then we distribute it to the fourth. 3x times a positive 4, so that's going to be a positive. 3x times 4, that's a 12x. And then we have positive 2 times a positive x. That's a positive 2. And then a positive 2 times a positive 4, that's a positive 8. When I did the distribution, what word happened with all four multiplications, all four products? Positive. And the reason why is because everything in here is a positive. Positive 3x, positive 2, positive x, positive 4. So when I multiply that, I have no choice but getting positive. And when I add and combine all my like terms, I have a 3x squared, positive 3x squared. A 12x plus 2x, that's a positive 14x. And a plus 8, a positive 8. So when I multiply something like that together, my answer has plus plus in it. Because the product, the factors that made this happen were both positive. Plus plus. That's something you need to remember. On number 10, in the parentheses, they're differences, they're subtraction. So when I multiply this out, x times 2x, that's a positive. Positive x times positive 2x. That's a positive 2x in the second. Positive x times negative 3. That's a negative 3x. Negative 7 times positive 2x. That's a negative 14x. And then we have last times last is a negative times a negative. Last times last is a negative times a negative. So it's going to be a positive. 7 times 3 is 21. So when we combine our like terms, we get a positive 2x squared. But in the middle, negative 3x, negative 14x, that's negative 17x. But the last term is a positive, positive 21. Original question was an x minus 7 times a 2x minus 3. So in the parentheses, the signs are both negatives. And when I multiply together, the last sign, this last sign, the last term, has to be a positive number. Because if these two are negatives, when I go last times last, it's going to be a negative times a negative. It has to be a positive. In that word FOIL, first times first is how we get the 3x squared. 3x times x times 2x. Last times last is how we get this last term. 2 times 4, positive 2, positive 4, gives me a positive 8. Negative 7 times negative 3, positive 21. Last times last is how we get to 21. When you factor, those are the four things you're filling in. You're filling in, what are my first and first things here? What are my last and last things here? That's what you fill in. The middle, I have no idea how to make the middle. I like to call it guessing and checking, very scientific. But what it becomes is educated guessing and checking. The middle is made out of oil. That's where the middle comes in. And OI stands for outside times the outside. And this is what we're checking, plus the inside times the inside. When you say out times out plus in times in, but the middle is made by going the two outer terms, that 3x times the 4, 3x times the 4 is the 12x, and the inside, 2 times x is a 2x, and that adds up to the 14x. The outside times the outside, x times negative 3, that's a negative 3x. Negative 7 times 2, positive 2x, is a negative 14x, and that adds up to negative 17. That's how we figure out the factoring. That's how we made our choices for these numbers. is we make the middle. So we check the oil. And the more you are disciplined about writing down your choices, the easier it is to see which pieces are going to fit in this puzzle. Both of these ended with a plus. The only way you're going to get a plus is if you multiply either a plus and a plus or a minus and a minus. So the only way when you're factoring, if you have an ax squared plus a bx and a plus a c, if it's a plus, it has to be plus plus in the parentheses. If you have an ax squared minus a bx plus a c, then that has to be a minus minus when you factor. If it ends in a plus and the middle's a plus, the signs have to both be pluses. If it ends in a plus and the middle's a negative, then they have to both be negatives. That's the only way to make the last term a positive. They have to be the same. Then you look at the middle. If they're all pluses, they're all pluses. If that's a negative and a plus, two negatives. The last option would be this. A plus bx but then a minus c. Or an ax squared minus bx minus a c. When I multiply this together, I get bx squared minus 4x plus 6x. But here's what you're looking at. Positive 6 times negative 4 is a negative 24. Negative 4x plus 6x, that is going to be positive 2x. But it's a negative 24. This is the only way to get the last term negative. To get a negative last term, these two signs have to be opposite, have to be different. The only way to get a negative last term is because the signs in the parentheses are different. So if it ends in a negative, we just need a positive negative. That's the only way to get a last term that's negative. Those are the pieces we got to figure out. Put up some problems that we want to factor. I'm just going to cherry pick this. Number 1. Read y to the third, minus 7 divided by y. We're going to do x squared to x squared plus x minus 42. Also do 3, 3x squared minus x minus 4. To 4, 10x squared minus 44x plus 16. The first step of factoring is always take out the greatest common factor. You don't want to sit there and try to factor bigger numbers if you can make them smaller. If they have something in common, take it out. Maybe we can make something smaller happen. So you look at the individual terms. That is an x to the third. Oh, so a y to the third. And when you're looking for the greatest common factor, look at the coefficients, a 3 and a 75. Is there anything that I can take out of a 3 and 75 that they have in common? 3. They have a 3 in common. So I can take out a 3. Here comes that factoring out. Y to the third and a y. Do they have anything else in common? Y. A y to the first. So if they went out to lunch, they could only spend 3y, because that's all they have in common. Okay, so it's going to be 3y times. Because we're factoring it out, we're dividing each one by 3y. So 3y to the third divided by a 3y. The 3 reduced. What's y to the third divided by y? Y to the second. And then a minus 75y divided by 3y. 3 goes into 75. No.
25.
25 times. And the y reduced, so this is 25. Now, before you start patting yourself on the back, directions are always going to say factor completely. So if you had like the number, let's say 24, and you go, hey, that's 4 times 6. And you say, all right, I'm done. Well, good job. Well, that's not factor complete. You can still go, that's a 2 times a 2, and that's a 2 times a 3. So 24 is technically 2 to the third times the 3. Factor completely. Okay. So now you look at here and say, all right, can I do this? Can this go any further? Well, 3y, and hopefully we recognize perfect square minus perfect square. So y, and that's plus 5 to minus 5. So if you recognize it, then you go straight to go put your $200. This is 3y, you got a y plus 5 and a y minus 5. Okay? If you recognize it. If you don't, just take it apart one little piece at a time. Don't forget to bring down the 3y. You know factoring looks like a parenthesis times a parenthesis because that's what we multiply together. So you got to kind of go backwards. What times what? First times first is y squared. So what times what? First times first is going to give me y squared. Y times y. That's the first thing to take care of. Then you look at the sign. It's always important. I don't care about the 25. I don't care about the middle. It's the sign. If you get the sign right, then we're on our way. Because here's the deal. I know y times y is right. Because that's the only way I'm going to get y squared. So I know that's right. The sign, you can never F up the sign. If you think about it, you can never get it wrong. And what I mean by that is, I'm not saying like, you can't get this wrong. I'm saying, if you think about it, there's no way to get it wrong. Last times last is negative. A last times last, that's got to be a negative. So these signs, they have to be opposite, positive and negative. That's the only way we're gonna get a negative. There's no other way. Has to be. So here's the good news. I know if it's gonna factor, it has to be a y times y. It has to be a plus and a minus. Then it's a puzzle. Do a puzzle, you gotta have the pieces on the table. Let's say we didn't know anything about difference of two perfect squares. There it is. Last times last is 25. What can make it 25? It might be 1 times 25. The next way would be a 5 times 5. So when I say that guessing and checking, so I'm gonna guess that it's 1 and 25. That's my first guess. Then you check the OI. Because you just don't guess and then leave it alone. Guess and then you check. We check that OI. Outside, outside, inside, inside, we add them up. Outside times outside, that's negative 25y. Inside, inside is a positive 1y. That adds up to negative. I don't have a negative 24y in the middle. So 1 and 25 is not going to work. So now think about it. You do educated guessing and checking. You think about it. We want no y's in the middle. We want 0 y's in the middle. We want the y's in the middle to cancel out. The only way the y's in the middle to cancel out is if I have a positive them and negative them. Oh, 5 and 5. I would get a positive 5 and a negative 5 of those y's. So you start to put the pieces together because I've done enough of these where I see a squared minus b squared, and I know this is the factoring for that. I start to recognize that this is y plus 5, y minus 5. And I don't have to go step by step. You can still check the middle, negative 5y and positive 5y. That's a 0 in the middle, and that's what this is. Okay. I know in the past, some of you may have been taught some other trick to, factoring, whatever. That if you're going to use that, that's fine. Just show the work. I'm not going to take that tool out of your hands. All I'm going to say is it's going to limit your ability to do anything in the next level. What I'm trying to show you is how to reason, how to think it through. Okay, not just put numbers in some kind of machine that gives you the answer. When I say machine, that diamond method, box method, whatever. Right? Reason. Think it through. Yes, and check. Talk to any math professor on this campus. Every time we sit here and we talk about factoring, and we talk about that whole special tricks that high school teaches you, we just get angry. That's ice cream time. Here, greatest common factor, x squared, x. This one doesn't have an x. That's a 1, that's a 1. They have no common factor. Nothing we can take out of 1. So no common factor. So if I'm factoring, I know when I factor, the answer should look like a parentheses times a parentheses. So I'm just going to put into empty parentheses. Because I know I'm going to multiply stuff together to get that answer. And then we focus on first times first makes x squared. The only way to make it x squared would be x times an x. It has to be x times x to make x squared. So I know I got that right. Then the signs. First times first, and then the signs. I'm not going to worry about anybody else, just the sign. The last sign is negative. The only way to get a negative, the two signs here have to be different. One has to be positive, one has to be negative. That's the only way I can get last times last to be a negative number. So I know it has to be x times x, and I know my two signs have to be 1 plus 1 minus. Maybe it's a minus here and a plus there. We'll find out in a minute. Then, last times last, what makes 42? Well, there's a couple of ways we can make a 42. It might be 1 times a 42. And what I do every time is I list all the possibilities. It's putting all the pieces of the puzzle on the table, so I know what I have to work with. Sometimes it's not obvious. 1 and 42. 2 times 21. 3 times 14. Okay. The next one would be 6 times 7. It doesn't take a long time to list all the possibilities. Six and 7, if you just look at it, since you want one x in the middle, the only possible combinations of these factors that make 42 that would add or subtract with each other and combine and make a 1x in the middle, 6 and 7 can combine and make a 1x. Because if I go 3 minus 14 or 14 minus 3, I'm not going to get 1. 2 minus 21 or 21 minus 2, I'm not going to get a 1. 1 minus 42 or 42 minus 1 is not going to make a 1. But 6 minus 7 or 7 minus 6 could make a 1. So I'm going to try, educated guessing check. I'm going to guess the 6 and 7 first. And then I'm going to put it in here. So here's my 6 and then my 7. Here's my 6 and there's my 7. And then check the middle. What? Outside times outside. X times negative 7 is negative 7x. Inside, positive 6x. Negative 7 plus 6 is negative 1x. I didn't want negative 1, I want positive. So here is the rule. Don't switch the numbers. If you have the right amount, I got 1x. You have the right amount with the wrong sign, switch your sign. Just switch your sign. This one should be the negative. That one should be the positive. Because if you switch the numbers, you might change the middle answer. Not necessarily in this problem, but in other problems. Now when you check the middle, x times positive 7, that's my positive 7x. Negative 6 times x, that's my negative 6. 7 minus 6x is going to do positive 1x. So I made a list of my possible answers for last times last. My best guess was 6 and 7, so then I plugged it in and I checked it. Well, we can take that educated guessing a little further. So if we had going to guess the 6 and 7, and it's going to take this a little further. We're going to guess the 6 and 7. We want positive 1x. So who should be positive, the 6 or the 7?
7.
The 7 should be positive. The 7 should be positive and the 6 should be negative because I know I'm going to add them together to get the middle. So when I choose the 6 and the 7, I'm going to think ahead just a little bit. And since I want positive 1 in the middle, my 7 should be the positive and my 6 should be the negative. So when I do outside, positive 7 and a negative 6. I keep using that, playing checkers, playing chess, don't take your finger off until you think about all the moves. Think ahead before you actually even show that move. As you're playing those games, you have to think ahead, watching what they're doing and thinking about the moves you're going to make. Think it. On HBO, there's a show called with Brian Gumbel, Real Sports. And on the show Real Sports, they did a little segment on a 11-year-old boy, immigrant from a country in Africa. He and his family. He is one of the youngest grandmasters in chess. His brother taught him the game since he was like 5 years old. And he can beat almost anyone. It's amazing. And he says when he's playing chess, in his head, he's seen like 24 chessboards, playing out all these different moves, thinking ahead, processing. Okay. And I have never been able to find the clip because everything is copyrighted. When people look, but it was amazing to hear him talk about how well he can just see things. And it's just like, we breathe there. He can't help but see it. Nerd. Not a nerd. X squared minus x minus 4. Is there a common factor for any of those? Yes, no? Do they have anything in common?
No.
Nope. Set up the parentheses. So this time, first times first is 3x squared. So first times first, the only way to make a 3x squared would be 1x times 3x. 1x times 3x. So now we have a little bit of a difference going on in the other questions. And check this out. Well, here's and again, talking about gradient. That's the only way to make 3x squared. It has to be x and 3x. The signs. The last sign is negative. So these two signs have to be opposite. One of them is going to be positive, one of them is going to be negative. I might have to switch them, but the signs have to be different. So the only way to make 3x squared, x and 3x, the signs have to be a plus and a minus. Those pieces are the right pieces. Maybe I might have to rearrange it, we'll see. Last times last is a 4. So again, I always write down on the side what makes a 4. It might be 1 times a 4, and that's always start with 1. It might be a 2 times 2. Because what happens, I will always see go straight to the 2 times 2. And they ignore the 1 and the 4. So if you just go straight to the 2 times 2, outside, that's negative 2x. Inside is positive 6x. That makes 4x. That's not what you want. If I switch the 2's, nothing's going to change because they're 2's. So 2's not going to be the answer. So then people just give up. Well, 2 didn't work. There's no other way to make 4. That's why you make a list. Now we'll try the 1 and 4. Now, try to think about 1 here, 4 here, or 4 here, 1 there. I'm looking at, I have 1 in the middle, so I'm going to want to probably go 4 minus 3. If I put 4 here, I'm going to get 4 times 3. That's 12. I don't want to get 12. But I'm going to put 4 here, 1 there. Now I'll check. If I don't get it, then I'll switch to 1 and 4. Outside, that's x times negative 4, negative 4x. 1 times 3x is positive 3x. Negative x and 1. You're playing with these pieces that make the product. And you're just trying to see how the puzzle fits together. But if you don't write down the pieces, you're going to miss something. And you organize one piece at a time. You're not supposed to go straight from here to the answer. Make the first turn. What are the signs? Then focus on the last one. I will always see people their students get carried away and they go straight forward trying to set up the premise. If you can factor out a greatest common factor, you would have a better chance of getting it right. Because right now, from 10x squared, it could be x and 10x, it might be 2x and 5x. 10x squared, 44x, and 16. What do they have in common? Common factor. Take out a 2. It'll give you smaller numbers. So if I take out a 2, everybody gets divided by 2. This is now 5x squared minus 22x plus 8. That's 2 times. We set up the parentheses for this part. So you got to factor it completely. But instead of trying to figure out what makes 10x squared, x and 10x, or is it going to be a 2x, 5x? The only way to make 5x squared, it has to be an x and a 5x. Now, I only have one choice for first times first. The sign. When we do the signs, you look at the last sign. The last sign is a positive. So the only way to get a positive, it's either positive times a positive, or we can get a negative times a negative and we get a positive. So there's 2 ways. If there's 2 ways, now you look in the middle. If this is a positive and the middle is negative, these 2 signs have to both be negative. A negative times a negative will make a positive, and the negatives in the middle are going to add up to a negative. Okay. So instead of needing all the factors for a 16 because you took out the 2, now we're just working with an 8. It's either 1 times 8 or 2 times 4. Fewer possibilities. So what do you think is going to make the 22? A 1 and an 8 or 2 and a 4? What do you want to try first? If I put 1 and 8, negative 8, negative 5 is negative 13. If I put 8 and 1, negative 40, I don't think we're going to get there. I don't think it's 1 and 8. 2 and 4. That's a 2 and a 4. That's negative 10. And negative 4, that's negative 14. We want 22. 4 than 2. Negative 2x. Negative 20x. There's negative 22x. So this is the factorization for this. Last one, I want to get to this one. If I told you to factor 6, 6 is equal to what times what? 2 times 3. If I say let's go factor 15, what is that?
3 times 5.
3 times 5. If I say let's factor 17, what's that?
1 times 17.
That's it. But that's a compound number because you can factor it. That's compound number. If you can only use 1 in itself, we call that what compound number is that? If the factors of a number is only 1 in itself, and this number is called a prime. If you can't factor it other than 1 in itself, it's a prime. So polynomials are the same thing. No common factor, you set up the parentheses. The only way to make x squared would be x and x. The last sign is positive, and we know if we're going to get a positive, it's either a plus plus or a minus minus. 9, it's either 1 and 9 or 3, 3. If I do 3, 3, I'm going to get a 6x in the middle. I don't have a 6x. So if I go minus minus, Because minus minus will give me a positive. But if I go x minus 3, I'll get a negative 6. I don't have a negative 6. Okay, I'll go plus and a minus because that gives me 0 in the middle. But if I go plus and minus, that's a negative number, not positive. I've tried every possible way of factoring this. It doesn't factor. This is prime. So you see how these factor this way? If you have a squared plus b squared, that's prime. It won't factor. The difference of two perfect squares factors, but the sum of two perfect squares doesn't factor. Now let's use imaginary numbers, but that's a different issue. That's a crash course in factoring, step by step.